Here is the schematic. At first glance, everything is simple. Resistors, capacitors, LEDs, transistors, a microcontroller. But if you show this schematic to a beginner engineer, they will see just a set of components and conductors. Today, we will look at how to read such schematics through the eyes of an engineer and where beginners most often make mistakes. At the same time, we will break down how a complex schematic can be divided into simple stages so that it stops being intimidating. Mistake number 1, reading by components, not by functions. The first and most common mistake is reading a schematic by its elements rather than by its functions. That is, a beginner sees a resistor, an inductor, a capacitor, a transistor, while an engineer sees a voltage divider, a filter, a transistor switch. And until you understand what a stage does, the schematic will seem frightening and chaotic to you. And a question for you: when did you first realize that a schematic is not just components but a process? Do you remember that moment? The second mistake, not understanding the physics of how the component itself works. For example, we see a MOSFET and we think, well, a switch is a switch. We need to understand the physics of its operation. Otherwise, a situation may arise where for a powerful load, in this case, of course, it is not so. Here we have a relay coil, but for a powerful load, we would need to turn this MOSFET on with a voltage of 10 volts. But here it is turned on with a voltage of 3.3 volts. That is, the data switch comes directly from the microcontroller pin. Thus, in this case, this circuit will work, but if the load here is more powerful, it may not fully turn on, heat up, and eventually fail. Tell me, has it ever happened to you that everything looks good on the schematic, but in reality it doesn't work? What turned out to be the cause? Let's move on to the third mistake, not seeing typical stages. That is, almost any schematic consists of repeating blocks. Filters, amplifiers, a voltage divider, as in this case. Here is a voltage divider made of resistors. Here we have a non-inverting amplifier on an operational amplifier. Here we have a voltage follower on an operational amplifier. Here this RC network forms a filter. When you learn to recognize them instantly, any complex schematic becomes clear and predictable. The fourth mistake is reading the schematic as a picture, not as a flow of energy. Current always flows from the source through the load to ground. If you do not understand this, do not imagine how currents move in your circuit, then you will never understand why there is a diode here, a diode there, why capacitors are placed here, and so on. The fifth mistake is not distinguishing analog and digital ground. Beginners often put everything in one pile, analog and digital, and then noise, jitter, ADC issues, unpredictable failures. Let's look at a separation scheme. Here, in principle, analog power is made from digital power and digital ground. The supply voltage is separated by an inductor, and the analog ground is connected through a 0-ohm resistor. In principle, you can also put an inductor or a Ferrite bead here. This prevents interference from the digital ground from entering the analog ground. Write in the comments, do you separate ground into analog and digital, or do you prefer one common plane? The sixth mistake is not understanding the purpose of protective elements. Beginners often ignore the installation of protection diodes and protective resistors, TVS, because everything works without them anyway. Yes, at the initial stage, the board works normalno, but then during debugging, the microcontroller suddenly stops responding on one of the interfaces. Mistake number 7. Trusting schematics without verification. There are plenty of incorrect schematics on the internet that visually look correct. If you simply copy them into your project without checking on a breadboard, or at least in an electrical circuit simulator, then with a high probability you can get a non-working board or instability during startup and debugging. You will save time on circuit design and spend 10 times more time debugging the board after launch. Have you ever caught errors in typical schematics from data sheets or the internet? It happened to me a couple of times. Now, all the schematics that I take from the internet or from other projects, I obfuscate in a test. Either assemble them on a breadboard or run them in a circuit simulator. Now let's look at the schematic again. Everything is the same, but now it becomes clear where the protection is, where the transistor switch is. This is how an engineer reads a schematic. He sees not just a set of components, but real physical components. He sees connection schemes, typical stages, and understands the physics of their operation. Therefore, the more schematics you analyze, the faster you begin to see the logic of how the device works, and not just a set of components.